Good day everyone, and a very warm welcome here from the STEINERT headquarters in the sunny Cologne. Before we start with our three-part online seminar series, I would like to briefly introduce myself. My name is Sasha, I will be your moderator for today, and our agenda. First, we will have a presentation by our expert of about 15 to 20 minutes. Afterwards, we will switch to a Q&A session where our registered users will have the opportunity to put their questions down below in the chat, where I will be collecting all of your questions and later forward them to our expert, so you will get your answers live. So, without losing any more time, please welcome to the stage today's expert, Patrick Lindweiler.
Many thanks for the brief introduction and a very warm welcome to today's online session with the topic The Many Futures of Plastics, Chemical and Mechanical Recycling. Nowadays we are talking a lot about plastics recycling and the many futures of its recycling, and often we discuss mechanical recycling procedures and also pre-sorting processes for the chemical recycling. A few of you may know about this topic already and are linked to this discussion, and maybe a few of you are new in this area. Today, we'd like to give you a brief look inside our activities to this topic. My name is Patrick Lindweiler. I'm responsible for product management waste recycling within the STEINERT group, and I'll guide you through the presentation in the next 20 minutes. And as we have only 20 minutes left to talk about the many futures of plastics, we'll skip an introduction about STEINERT and our key figures. I'm pretty sure that you are familiar with STEINERT and more interested in the main topic following now. On the other hand, I'll get in trouble with our marketing team, to Sasha, that instructed me to be brief, and they are not to be joked with. So let's start. I've taken a few diagrams from Plastics Effect 2022 Plastics Europe as start slides, as they show what's going on in Europe in 2021. Here we see that the plastic converters demand in 2021 was about 50 million tons. Mainly packaging and building and construction sector require the plastics, followed by the automotive section. And with a closer look into the plastics types, we see that roughly half of the plastics types is polyolefins, so PE and PP. And what about the development within the last years? Here we see that landfilling of plastics is decreasing strongly, and energy recovery plus recycling is growing and growing. The good news here, as long as recycling grows, our market grows also, and options to close the loops. But where is our market, and where can we still grow with the market? This question can be answered by using this diagram from Plastics Effect. In 2020, roughly 30 million tons of post-consumer plastics waste were collected in the EU. And recycling rates are 13 times higher when collected separately compared to mixed waste collection. Potential for our markets can be further on generated via the material still going to incineration and landfill. About 40 million tons from mixed waste collection and 5 million tons from separate collection are waiting to be treated and to be recycled. And our mission together must be closing the loop, as otherwise we are trapped. We are trapped in the climate change, we are trapped in the environmental pollution and in the consumption of resources, as this picture shows. The linear model of industrial value creation is reaching its limits and is out of date. Dismantle, produce, consume, throw away does not longer fit into time. We need a circular economy, and we are working on it worldwide. The circular economy covers the whole steps and links them to a circle as shown here. Raw material production, distribution, consumption, collection after usage, recycling and closing the loop are the main parts of this circle. For sure, there are still some bypasses where material can get lost, but also here we'll find solutions in the future. So let's go ahead with the recycling and the many futures of plastics. There are so many ways available taking a look into recycling. We've tried to take a look at the following applications. First of all, for the sake of completeness, the repair and reuse, followed by the dry and the wet mechanical recycling process and the dissolution for the plastics, still a mechanical recycling procedure. Then we skip to the chemical parts. This is the depolymerization, the pyrolysis, the gasification, and last but not least, we have the thermic recycling, the incineration. What we already can say is the closer we get to thermic recycling and incineration, the more material gets lost and the more complex the material mixtures get. And with a closer look on the recycling of plastics and the production of plastics in combination, we've tried to visualize the way via a simplified sketch as followed. In the middle is the recycling procedure, and on top with the plastics manufacturing sketch, very simplified here, with a refining section, with a hydrocarbon processing, with a polymer production, and the plastics processing also. The different plastics can find their way via the specific recycling applications in the plastics manufacturing, as for example shown here. So the PE, the PP, the PS, the PES and other plastics can find their way as recyclates via the dry and wet mechanical recycling procedures into the plastics processing. The PS, PP, PA and so on can find their way via the dissolution as polymers into the plastics processing, and this is still a mechanical part. Then we skip to the chemical recycling procedure. Here we see that PS, PET, PA and so on find their way as monomers via the polymerization into the polymer production. The PE, PP, PS once again find their way via pyrolysis as hydrocarbon mix into the hydrocarbon processing line of the plastics manufacturing steps. And last but not least, we have the mixed plastics waste, finding their ways via gasification as synthetic gas in the refining procedure of the plastics manufacturing steps. And related to the application and way of recycling, they can find their way back into the loop. So our mission and our motivation is closing the loop via the different solutions for mechanical and also chemical processes, and via creating our individual process steps in this recycling industry. Starting with an example, for a dry mechanical recycling step, often waste streams are pre-sorted coming from light packaging waste, commercial demolition waste, commercial industrial, MSW, bulky waste, household waste, and so on, with the target to recover already in a very early stage the products as, for example, the PP, the PE, the PET, the PS and other materials, as mentioned here, the Tetra Pak, the wood, the paper and card and the metals and textiles, but we'll stay with the plastics today here. So the material can look like right-hand side shown PE products here baled for transportation and further recycling steps. Concepts are often customized but also often follow a rough red line with pre-treatment via shredder, bag opener, shifter technology, the screens, before the material is moved forward to magnets, eddy current sorting systems and optical sorting units, the Unisort. The plastics are then sorted separately into the specific bays for baling as mentioned here. We see here that the waste is pre-treated, specific lines for fines, for medium, for coarse fraction, and also split into heavy and light or 2D and 3D. The material is usually forwarded to the magnets and eddy current sorting systems to recover the metals. Before the waste streams are sorted with sensor technology, so the optical sorting systems into the different products, the plastics, ready for baling. Pre-sorting is often followed by purification steps. Here the already pre-sorted materials are once more cleaned via mechanical sorting steps. Impurities are removed and plastics are upgraded in their purity and in their value. This can be done by sorting the specific types of material additionally already into the color and into nice products as shown here on the right hand side, yellow items. The concepts are similar to before mentioned flow diagram, but already optimized for generating high quality products ready for the recycling. Once again, a pre-treatment is required, similar to before mentioned process with bale opening, with screens, with shifter technology, followed by magnets and eddy currents to recover the metals, before the material is then sorted again via sensor technology, so the optical sorting systems with often rougher, cleaner concept. In the end, a scavenger increases once again the yield of the whole application. Products are, for example, color sorted and purified products ready for the recycling industry. Often, these products find their way into the dry mechanical and wet mechanical recycling facilities where recyclates for the plastics production industry are produced. Here we are talking about recyclates made of PE, PP, PET and so on, and these recyclates can directly be used in the plastics processing part of the industry. The concepts and recycling steps are optimized for the fine particle sorting and flake and granule quality control in a combination with dry mechanical process steps and wet mechanical treatment. Here it's very important to meet the required specification related to purity and metal-free requirements. Often once more neodymium magnets and special adhesive fine systems are used here with a special designed pole system and the 4T technology. The ECS fines recovers less 1 mm aluminium fines as a purification step for plastics, for example. Downstream, once more, finalize Unisort sensor sorters control the material quality by using near-infrared technology and color detection, so that in the end the material specification matches with the operator's demands and extruders work under optimal conditions. But what about the plastic that further on cannot be recycled via a mechanical way? Additional ways are required here via physical and chemical recycling steps as mentioned on the slides before already. In-feed is pre-sorted plastic waste, but also residues from prior sorting steps. But also these material streams need to match with the specifications required for the chemical processes. So the definition of chemical recycling is often under discussion and indeed not clear if one follows the discussion. For us as supplier for sorting technology, often the chemical point of view is difficult to understand. The chemical recycling process requires also a specified quality of plastics and the limit of impurities, as otherwise the process is harmed or the quality of the chemical product decreases. Sorting steps are once again very individual. Often magnet technology is used to sort the metals, and often once more Unisort optical devices are required to meet the requested specifications of the material morphology for the different chemical processes. So here we see in the flow diagram as an example, of course, the pre-treatment with shredders, with debalers, followed by screens and shifter technology. Magnetizable items are removed by magnets and aluminium items by the use of ADC technology. Following the Unisort rougher cleaner concept, the material is sorted to meet the chemical requirements. For sure, the differentiation of 2D and 3D can be taken into account if required, but often the 3D material already takes the way into the mechanical recycling, so that we are here in this application are more specialized on the 2D film application. Here we use the Unisort film technology mainly. With this technology we are able to process even very light foil with an optimized throughput and a really good quality. So the active object control, the so-called AOC technology, helps a lot to keep the light foil in a stable position for the detection and the sorting procedure. Last but not least, often material follows the way into the incineration plus minus the use of energy and thermic value. This is compared to all the other prior options the least preferable solution for plastics, as this way cannot close a loop anymore. incinerated plastics and its values are leaving the loop. In the end, there will be waste and residues available on the market that needed to be treated. A last usage is incineration, and the better way instead of landfilling. Also here, requirements in regard of the chlorine content have to be taken into account, as otherwise the boiler and burning rooms are harmed. The concepts cover magnets often and near-infrared sorting steps to recover the PVC as an impurity, as shown on this slide and this picture. Yeah, that's it for today's main topic. But how are we going ahead? What is interesting in the future also, and what have we learned today? There are so many points in focus, and we'd like to mention only a few here as an outlook. On one hand, we'd like to use more data related to specific waste items themselves, as for example the attributes linked to a digital product passport. Here we are working together in a community with R-Cycle, where a lot of data is generated for the future applications. AI and digitalization will play a role also by using more information and linked data. For sure, plants need to be upgraded to meet the specific requirements of the products to be used in the mechanical and also the chemical procedures. Learnings from the past and also learnings in the future need to be taken into account, also as there are often nowadays very specific demands for sorting and recycling. What have we learned today? Here again a few key points and messages. There's not only mechanical recycling on the market to go ahead with. Mechanical and chemical waste are open and needed to close the loop for material, and they do not really compete. We have solutions available by the use of magnets, ECS systems, and a large variety of sensor sorters, the Unisort technology for example. And only together it's possible to grow and to close the loop to get the waste streams used for recycling. That's it for today's session, and we hope you have followed us with interest. And we'd like to close the session with a nice picture shown here coming from mechanical recycling and our way additionally looking into the chemical recycling industry also. That it's for today's session, and now it's time for Q&A, and we are pleased if you have still some questions for us to answer. So I'll hand over back to Sasha, who has collected hopefully a lot of questions to be answered. Thanks a lot. Sasha, what's going on?
Thank you again for your presentation. You kept it short and brief, as I imagined. Thank you very much.
You're welcome.
And there were only a few questions actually, but one we get most of the time.
Yeah.
What about black plastics? So the actual question was, when controlling black plastics composition, what is the detection limit of black plastics?
That's a really good question, and very, very often we hear from this question on exhibitions and when we talk with customers and when we're in a test facility and this kind of stuff. So in the end, black plastics are not near infrared detectable regarding the different types PE, PP, PET and so on. But we have technology that is able to sort a mix of these plastics via Unisort Black technology as a mix of this black plastics. In the end, this can then be forwarded to the plastics recycling industry, where we use the Unisort Black Eye technology. And this is technology that we developed in the middle infrared spectrum, where we can distinguish between PE, PP, PS, PET and so on, and can sort these materials. And in total, in the end, this material is then forwarded to the recycling industry and back into the loop, into the production of plastics. And that's a facility, for example, running in southern Germany, making these water tanks, these black water tanks, for example, to close the loop in the end, also with the black plastics.
Yeah, so if you're interested in the topic of black plastics, go to our website, steinert.de, and search for the showcase of Graph, and you will learn more about it.
Mm-hmm.
So the same viewer had another question. What do you mean with magnetic technology on plastics? And I think there was a misunderstanding, but you can explain.
It's okay. That's a nice question. Often plastics are shredded, and often we have still some composites. For example, in the plastics, after shredding, they are hopefully liberated, but there is aluminium often in, and whatever kind, any kind of ferrous particles. And with the magnet technology, so with overbelt magnets, with neodymium drums, and in a combination with eddy current sorting systems, we remove all these metals as an impurity, so that the plastic granules and flakes, and also before the sorted plastics in the light packaging waste facilities are already purified for the plastics production industry. Yeah.
Okay. Another question from Leah: which material fractions after the sorting plant are the best for chemical recycling?
Okay. That's a good question, and it's a question that we have to answer very carefully, honestly speaking, because we do not want to get in competition to the mechanical part. So usually whatever we can sort nowadays and that we forward to the recycling industry can be used in the mechanical, via the mechanical way and close the loops. But there are still some leftovers that the mechanical recycling application cannot handle, and these are the plastics that hopefully usually then in the future will pass to the chemical industry to give this material back as polymers, as monomers, as synthetic gas, and this kind of stuff back into the loop to close the loops.
Okay. Then there were two questions we cannot really answer right now, or are not allowed to talk about it at the moment. So do we have a chemical recycling plant in our portfolio? Nothing we can comment.
No, but I can answer that for sure. Yeah. Also we are not allowed to tell these customers' names, but we have technology in this area running with good success. Yeah, and maybe in a conversation later on the phone, although we can talk about the concepts and the way to this chemical sorting procedure and the concepts for sure. But we are not allowed to mention these companies here right now. You see, there's a big competition between these companies, and we need to be careful. Yeah.
Okay. Ruben asks, how do you monitor the performance of the machines? And do you combine the data of your machines? How do you evaluate the process?
So there are two things. So all the data generated by the near-infrared system or from all the sensors are tracked in the system themselves. So all the information about the morphology, about the grain sizes of the material, and so on is shown on the displays. Is forwarded via interface to the operator's system. So this is material information that is used. On the other hand, we have the information, the digital information from the system itself. So compressed air setup, power consumption, heating of the light bars, and so on. This is tracked also and is used for maintenance teams and so on. And for sure, you can link this information. So whenever you have the first sorting unit in the drop and in eject, you have mostly, once again, near-infrared technology or sensor sorters following. And this both in combination can go ahead you can use this information to do a calculation how good the sorting performance of the prior sorting step was. And this, we do this for sure, yeah.
So one users, or actually 3 users now, are interested in the state-of-the-art for washing post-consumer plastics. Can you comment on that?
There are so many different ways to go ahead with washing, depending really, honestly speaking, on the material itself, where it's coming from, light packaging, or is it coming from the automotive industry. I would prefer to get in contact to the people that ask these questions to go into more detailed discussion after this session.
Yeah. So maybe we can show now the contact details. So you can contact Patrick or the STEINERT marketing department as well, and we will forward your request to the specific area managers. All right. Thank you also very much for all the congratulations on our good presentation. And Yeah, so there's one person who will contact you afterwards.
Perfect.
So yeah, thank you very much. I had one question still in mind. When you were talking about Unisort film, you were talking about 2D plastics, but can you also use it on 3D plastics as well? So a mixed plastic fraction?
Yes, that's for sure possible. So often our customers have in mind that the Unisort film is really only for the light materials. Honestly speaking, we have a few customers that prefer to use Unisort film technology also with the mixtures of 2D and 3D. As they see that they have advantages regarding rolling 3D items. For example, they are stabilized also, and in the end it's the same technology, so the same sensor used for standard 3D things. The only upgrade with the Unisort film is the AOC technology to keep the material via high belt speed on a stable position. And we can sort 3D also and 2D in a mix, or only 3D, so everything is possible. Yeah.
Okay. Yeah, that's it for the questions from the chat. You will see I left out a few, but rest assured we will contact you after our online seminar session by our area sales managers. And yeah, what is left for me to say is thank you for joining, and don't forget to register for the next week's event as well, when we are going to talk about the pure grade wood sorting. Patrick, thank you again for your presentation, and
thanks a lot also
we will
to
see
the
you soon.
community following us here with this presentation today. Yeah, it was a pleasure speaking to you. Thanks a lot. So that's it.
Bye.
Bye bye.